Today we are going to start with a fantastic conception which is called Catalan number. We have heard about prime numbers, but Catalan number is a new name to us. This Catalan number is widely used in combinatorics problems. Not only in combinatorics problem, in different field, in different applications, in computer or in robotics, in everywhere this Catalan number is used. But as far as our JEE Advanced is concerned, since JEE people, they always try new things every year, they can give this Catalan number problem anytime. And I will take examples while doing the class. So you will understand the importance of Catalan number. Don't skip the video, see till end, otherwise efforts from both the ends will go to vain. You will not understand anything, neither I will be satisfied that I haven't taught you properly. So there is a request, see the video till end. So let's start the class. This sequence, which is 1, 2, 5, 14, 42, this sequence is what called your Catalan sequence. Now, how this sequence is coming, that is very important to understand. Because you can say, sir, okay, it is one of the sequences that we have learned. But what's the big deal? Yes, we will learn how this Catalan sequence is formed and how we can use this Catalan sequence in our problems. And the best way to understand Catalan sequence is by taking an example. So let's take a famous example which is called your Dyke path. We will understand Catalan sequence through this Dyke path problem. Okay, let me take 8 into 8 square. This is 8 cross 8's grid. Okay. Now let us say this is the starting point and this is the destination. A person is started his journey from this starting point S and he wants to reach at this point, which is your destination D. He will move only along the border of this grid, and each and every path are of equal length. He can move only up or right. He will not move down or left. In how many different ways a person can reach from point S to point D? Now you people are thinking, sir, this problem we have already done in combinatorics. How this problem is related to the Catalan number? This we have already done. We know that there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 right movement and there are 8 up movement. So total there are 16 movements. So total number of ways in which the person can reach from S to D while moving only right and up direction is factorial 16 divided by factorial 8 into factorial 8. This we already know. This is the total number of ways the person can reach from S to D. Only by moving in the right and up direction. That's it. This we know. But no, here is the twist. Suppose I have said This is the diagonal. Now I have said in how many different ways the person can reach from S to D without crossing this diagonal. Are you getting the point? Without crossing this diagonal. That is, the person can come like, I'm taking one path here. Suppose the person is moving like right, up, right, then up, right, up, right, up. This is one way of reaching from S to D. And it is the path where the person has not trespasses the diagonal. Is it clear? So we will term this path, this kind of paths, as good path. Good path means the person is moving from S to D but not crossing the diagonal fence. Clear? That is a good path. But the moment that person crosses the diagonal, it will be a wrong path. Now think about it. Factorial 16 divided by factorial 8 into factorial 8. This is the total number of ways in which the person can reach from S to D in any path he has chosen, maintaining that he is moving only up and in right direction. This is the total number of ways. But I don't want that. I want those paths which will be below the diagonal, or at most he can touch the diagonal. There is no problem. Like this, the example that I have taken here. He is touching the fence at this point. No problem. That is accepted. But you should not cross it. This kind of problems can be solved by Catalan number. That we will learn. How that Catalan number is generated, that we will learn. Okay, so let us do one thing. Let me erase this portion. Now, I will tell you, suggest me one path. Suggest me one path where he is trespassing the fence. Okay, that is the diagonal. Let me say right. Then up, then right, then up. At this stage, he is crossing the line. So up, then right, then let us say right, then up, right, up. Is it clear? So you see, at this stage, at this place, I should say that he has crossed the border. So I made a division at this point. Now, this is a bad way. Okay. Now let us consider a good way. Let us say right, up, right, up, 3 rights, 2 ups, then 1 right, 1 up, then again right, up, then right, then up, 4 ups. Okay, this is a good way. Now you have to see a very important thing here. This is a bad way. In this bad way, you will find where I put this bar sign, here your right movement is less than, here your right movement is less than the up movement. Yes or no? Here, how many number of right movements are there? 1, 2, 3, 4 right movements. But we are having 1, 2, 3, 4, 5. 5 up movements. So this is a bad way. But you see, in the good path, what you can see, everywhere, at any stage of this sequence, you put a bar sign. You will always find that your R is always greater than or equals to the up movement. Anywhere you put a bar sign. You see, here there are 3 R's, 2 up. Then again, right, then you up, right. Anywhere you put a bar sign. Suppose if I put a bar sign over here. Now see, how many number of right movements are there? 1, 2, 3, 4, 5 right movements. Up movements, 1, 2, 3 and 4. So your right movement is greater than the up movement. Yes or no? Everywhere for a good path or a good way, your right movement will be always greater than or equals to the up movement. But it will be a bad path when your right movement at any stage of this sequence, right and up movements, at any point, your right movement will be less than the up movement. And the moment this thing happens, we will say that it is a bad path. Is it clear to everyone? Have you understood? So now, how to find out the number of good ways? Very simple. If this is our total ways, then what we will do to find out the good ways will be total ways minus bad ways. That's it. And that will give us the number of good ways. Good ways means the person is moving along the border in up and right direction, but below the diagonal. That's a good way. Okay. So now whole problem has been focused on how to find out the number of bad ways. That's it. So now our prime goal to find out total number of bad paths or bad ways. Bad paths or ways. Okay. Now, just now I told you that for any bad path at any point you will find in that sequence, first you take any sequence from the starting point to destination. Now if it crosses the fence or the diagonal, at that point you will find that your right movement is less than the up movement. That's for sure. That we have already seen. The moment the right movement is less than the number of up movement, it is a bad path. Clear? It is a bad path. So now, one of the bad path is what I have written over here is RRR, the example that I have taken. Here I put a bar sign because this is the point where it is trespassing the diagonal. Then R, up. Okay. In this case, we will find that your R is less than the R movement. The right movement is less than the up movement. But here you see your right movement is greater than the up movement. Okay. Now the question is, the big question, sir, how I will find out the bad ways? How I will find that at which point the person is crossing the fence or the diagonal? The one best way to see is that the point where R is less than U. But there can be many cases. How to do that? I have to get one simple form so that we can understand that whenever this is happening, this thing will happen. But how to relate that? For that, I'm doing one thing here. Look it very carefully now. I'm doing one thing here. After this point, the point where it crosses the fence, means it's a bad point. Already it's a bad path. He has already crossed the fence. Now even if he comes down the diagonal, it doesn't matter to me. It is a bad path. So what I will try to do, in the right side of this bar, I will interchange R with U. That is, the right movement will be replaced by the upper movement, like upper, up, up, and this up movement will be replaced by the right movement. Is it clear? Now you will ask me, sir, what's a big deal? Why you have done this? Now you observe carefully, very carefully. After doing this, you see, this is the whole path where actually the person has moved 8 right movement and 8 up movement, right? There are 8 right movement and 8 up movement to reach that point D. Now, in the second case, what we have considered, what is the second case that we have considered? That now our movement is R, 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 U, U, R, triple U, then U, 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 R, R, U, R. In this case, you observe carefully, your R, how many number of right movements are there? 3, 4, 5, 6, 7. And how many number of up movements are there? It is 9. So for every wrong movement, every wrong path, the person used to travel 7 left and 9 up movements. 7 right and 9 up movements. This is a wrong way. Are you getting the point or not? Every time you will get that there is 7 right movement and 9 up movement for every wrong path. You see, now we are actually having our 16 movements. Total, there are 16 movements. Here also there are 16 movements. But actually the total number of ways is what? 8 right movement and 8 up movement. But in wrong case, we are getting that there will be 9 up movements and 7 right movements. So you arrange this series, in any ways. At some point, you are definitely going to get your right movement is less than the up movement. And this actually signifies that the person has taken a bad path. So total number of bad ways will be, total movement is 16, that's okay. But there are 7 right movements and 9 up movements. So this is the total number of bad paths he has traveled. Are you getting the point or not? So remember in this way that whenever it's a right path, your right movement is always greater than equals to the up movement. But the stage, at any point of this movement, your right movement is less than the up movement, it becomes a wrong path. That is, it has already trespasses the diagonal. So it is our wrong path. So for that, we will always get, after interchanging the right and up movement in the right side of that bar, we will always get that there will be right 7 movements and up 9 movements. So these are the cases where the path is a bad path. Clear? Therefore, the total number of ways, that is, the total number of good ways will be the total number, that is factorial 16 divided by factorial 8 into factorial 8 minus this bad ways, which is factorial 16 by factorial 7 into factorial 9. That's it. Okay. So now let us try to generate the Catalan number formula. See, if there are n into n grids, then there will be n right movement and n up movement. Yes or no? Total number of ways is 2n factorial divided by factorial n into factorial n. This is what? This is the total number of ways of reaching from S to D. Now, what is the bad path? Bad path is 2n factorial, because you see in this case also there are 16 movements, but one right movement is less and one up movement is more. So in this case, the left movement will be n minus 1 factorial and the up movement will be 1 n plus 1 factorial. Yes or no? Therefore, this can be written as 2n cn minus 2n c n plus 1. Yes or no? And this is what is called your Catalan number and is denoted by Cn. Is it clear to all of you or not? Have you understood this conception? So those who have not understood this conception, I will request all of you to please see this video again, particularly at this proof part. Then you will understand the fact. Okay? So now let me just simplify this Catalan number, which we got actually Cn is 2n Cn minus 2n Cn plus 1. If we, simplify a little bit, we are going to have divided by n plus 1 factorial, n minus 1 factorial. Let me take 2n factorial common. At the same time, I am taking factorial n and n minus 1 factorial common. So we are left with 1 divided by n minus 1 by n plus 1. So if I simplify, we are going to have, this is coming like n plus 1 minus n divided by n into n plus 1. So that gives us 2n factorial divided by n factorial. Here there is one n and n minus 1 factorial is there. So it can be written as factorial n also. And in the denominator we are having n plus 1. So this can be reduced to the formula 2n Cn divided by n plus 1, which is nothing but your Catalan number, which is denoted by C suffix n. So this is what your Catalan number is all about. Is it clear to everyone? Now you can see this. Your C1 is 1, C2 is 2, C3 is 5, C4 is 14 and so on. Let me just check through this formula that what our C4 is coming. Actually, our C4 is coming to 14. Now let us verify the formula. We are having C4 is 8C4 divided by 5, which can be written as 8 into 7 into 6 into 5 divided by 4 into 3 into 2 and 5 is there. Okay. So let me just cancel this. 4 to 8, 3 to 6. So it is coming to 14. So what we got? We got C4 as 14 as the sequence I have shown you in the beginning of the sum. So now you can find out any Catalan number, C5, C7, whatever it is. Is it clear now? Now you see, a very important thing also we can deduce from this one, that all the points which are below this diagonal, these are all the lattice points. Suppose if the point S is our, let us say 0, 0. This point is the origin. And this point will be 8, 8, right? And you see this line, the diagonal is basically the equation of the line y equals to x. Now, all these points, all the vertices of the squares below the diagonal, these are all lattice points. And all the lattice points which are below the line y equals to x are the good lattice points. And the lattice points which are above the line y equals to x are the bad lattice points. We can say in this way, all the coordinates which are below the diagonal, all the vertices of these small squares that are formed in the grid, they are all lattice points. All these lattice points are good lattice points when they are below the diagonal or below the line y equals to x, and all the points which are above the diagonal are bad lattice points. Even the lattice points on the diagonal, they are also considered as good lattice points. Is it clear to everyone? Absolutely. Okay, let me take one example. In this question, the number of monotonically increasing functions from set 1, 2, 3 till 8 to itself. Means if this set is A, then your function is defined from A to A. Okay? With the property that fx is greater than equals to x. What is fx? Fx is basically your y. So in this case, we have been said that your y is greater than equals to x is equals to this thing, whatever they have given. Now you have to find out the value of k. That's the question. Now the first thing that will come in our mind, that actually they are talking about the Dyke path. You can ask me, sir, how you have understood this? The point is, whenever you find that they are giving you a condition where the path or the points, whichever way you say, is not crossing the diagonal. The equation of diagonal is y equals to x. So it is not crossing the diagonal. Either it is below the diagonal or it is above the diagonal, but not crossing the diagonal. Always think about Catalan number, right? In this case, let me draw the diagonal for this set which is given to us. Let me first draw it, then I will explain. So this is our diagonal. Now observe carefully. They have said, let me just do one thing. This is our starting point. Let us consider this point, the starting point, as the origin. And the destination point D is basically your 8, 8. Okay? Because we are having a set of elements 8, as well as in set B, it also has 8 elements. So it will be a grid of 8 into 8. Okay, now what they are asking for. This is our x-axis. Let me just denote those points. 1, 2, 3, 4, 5, 6, 7, and 8. And this is our y-axis, the vertical one. It is also 1, 2, 3, 4, 5, 6, 7, and 8. Okay? So, in this case, what they have said? They have said that your y should be always greater than equals to x. Let me do one more thing. You will understand the thing better. Let me just draw two sets first. What are the given conditions? That it has to be monotonically increasing, as well as your fx is greater than equals to x. So this is A, this is again A. Now I will show you that they are actually talking about the Catalan number. Try to understand this. Let me take one point. For an example, let me take a point, let us say 2. When x is 2, your y can be either 2 or 3 or 4 or 5 or 6 or 7 or 8. Because your y is always greater than or equals to x. So the value of y, that is your f of 2, that value can be either 2, 3, 4, 5, 6, 7 or 8. So your x equals to 2 can be mapped with any of these points from 2 to 8. Am I correct? Similarly, your point 4, this is x equals to 4. This can be mapped with any point from 4, 5, 6, 7, 8. Because here, every case, the condition is satisfied if x is greater than equals to x. But there is a twist. Let us say that your 2 is, let us say this point. That is, f2 is basically your 5. Now let us consider f of 4. f of 4 is, let us say 7. Now if I consider f6, and now your f6 is coming to, let us say, this point, which is your 6. Now in this case, look at very carefully. In this case, your fx is greater than equals to x. That is true. But is it monotonically increasing? No. Why? Because f2 is 5. Your 2 is less than 4 is less than 6. So if it is a monotonically increasing function, then f2 will be less than f4 less than f6. f2 is 5 is less than 7 less than 6. This is wrong. So you cannot arbitrarily choose these points. Are you getting my point? You cannot choose in this way because it will satisfy if x is greater than equals to x, but it will not going to satisfy the condition monotonically increasing function, right? So now what to do? Okay, let me do one thing. Very interesting thing. Please look at very carefully. Now let me do one thing. Let me choose a path above the diagonal. See, your Catalan number, as I told you right now, that the points, that the lattice points, which are below the diagonal are, I told that they are the good lattice points. But in this question, they are actually talking about the lattice points above the diagonal, including the diagonal. It should not trespass the diagonal below. So in this case, our good lattice points are all points which are above the diagonal. So now what I'm trying to do, listening very carefully, very interesting. You will find out the relation between this problem and the Dyke path. And eventually we will use the Catalan number. See this one. Now let me just choose one path. Let me just choose one path from this point till 8, which is a good path. Let me say I have started from this point, I move till this, then I come to this, then let us say this, then this, then this, then this, again this, then this, then this, then this. Is it a good path? Absolutely, it is a good path. Because I have not trespasses the diagonal. Isn't it so? I have not trespasses the diagonal. Now let us see whether this path satisfies our Dyke path or not. See, in this case, when x is 1, according to this path, when x is 1, what is your fx? Tell me, what is your fx? Your fx is coming to this point, which is nothing but 2. Okay. Now, when your x is 2, you see this path is actually touching the point, the lattice point 2, 3 or 4. You can choose any point. Any point you like, you can choose. Let me choose it is 4. So your f of 2 is 4. In this case, it is f of 1. Okay, when x is 3, what happened? When x is 3, the point is either this or this. Any point you can choose. Let me choose this point. This point is basically 4. So f of 3 is 4. Then what about your, f of 3 is 4. Yes. Now what about your 4? It is touching the point, the lattice point, this one. This is basically 5. So when x is 4, your f of 4 is 5. When x is 5, it is touching this point, which is actually 5. So f of 5 is 5. When x is 6, it is touching the point, this one. This is basically 7. So f of 6 is 7. Now when x is 7, it is touching the point this, which is actually 7. So f of 7 is 7 again. When x is 8, it is touching the point 8. Now please see whether this path satisfies our both condition or not. That's it. If it satisfies, then whatever good path means all the path above the diagonal in this case, because your fx is greater than equals to x, will resemble to the Catalan number. As simple as that. Please check this one. First of all, fx everywhere is greater than equals to x. This is satisfied by simply looking those 8 values. Now, is it a monotonically increasing function? Let us check. 1 is less than 2, less than 3, less than 4, less than 5, less than 6, less than 7, less than 8. So, if it is a monotonically increasing function, your f1 will be less than f2, less than f3, less than f4, f5, f6, f7, f8. Since it is a monotonically increasing function, so they can be equal also. I don't mind. Okay, so let us check. F1 is what? 2 is less than equals to 4, less than equals to 4, less than equals to 5, 5, 7, 7, 8. Yes, it is satisfying. So any path you choose above the diagonal, which is a good path in our language, in Catalan number language. So every good path will satisfy the lattice points that we are actually getting, will satisfy the given 2 conditions. Therefore, have you understood this? Now you can make a bijection between the Catalan number and the type path in this problem. So, in this case, your answer will be the Catalan number of A, that is C8. That's it. That's it. Because this is what, these are the A. Why I have taken C8? Because here N is 8. Here N is 8. Therefore, the Catalan number C8 will give us the total number of ways of mapping this function, which is monotonically increasing, as well as your fx is greater than equals to x. That's it. Okay. So what is your C8? C8 is actually 2n Cn, that is 16 C8 divided by 9, which can also be written as, now it is simple calculation. 16 C8 can be written as 16 over 8 into 15 C7. So that gives us 2 over 9 into 15 C7. But according to the question, it has been given this. So after comparing, we are getting K is 9. That's it. So if you know the Catalan number, and if you can understand that this is a question of Catalan number, whenever, you see, I always think in this way. Whenever you find that the question is above or below the diagonal, I always think about Catalan number. Right? So, if you know the Catalan number, you can do it in minutes. But if you don't know Catalan number, then you have to do a lot of permutation combination here to get the answer. Because now you will say that your 8 can be mapped with 8. So your 7 can be either mapped with 7 or it can be mapped with 8. When 7 is mapped with 7, then 6 can be mapped with 6 or 7. Or when 7 is mapped with 8, your 6 can be mapped with 6, 7, 8. And all those calculations, counting, you have to go for to find out the answer. Is it clear? So I hope you have understood the Catalan number. And I hope you have enjoyed the class. See you tomorrow. Till then, take a very good care of yourself. Thank you so much.